Hello there, chums. It has been much long time since we've had a video, so let's get back into it. This is our section 7.6 video. I'm writing in a lovely purple today because I'm feeling in a royal mood. This is the final section of the chapter, and all we're going to do is, instead of looking at systems of linear equations, we're going to look at systems of linear inequalities. And the essential question is just how can I represent these inequalities? And I'm going to be doing it on a graph. Now, before you freak out, let's just take a look at what we're doing today and how it relates to things we've done in the past. Notice we have two equations here and two variables. But instead of equations, I probably shouldn't have said that, we have inequalities. We have greater thans, we have less thans. Now, what we did right before midterm was we learned how to graph one of these at a time. This is the thing where you graph the line and then you pick the right direction in which to shade. Now we're going to graph them two at a time because this is the section where we're doing two equations with two variables. So let's just start by graphing these and then we'll kind of talk about where the solutions are. But I promise you, we really have done this before and we're really not adding any new layer. So y greater than negative x minus 2. The y-intercept's negative 2, and I'm going down 1 over 1. Remember that when I have a less than sign, it means that I need to use a dotted line. So I'm dotting my line here. Here are some dots. Here are some dots. Okay, so there's my line. It's not a very nice dashed line, but it'll do. Now, in the past, I told you that you should plug in a test point to figure out which way to shade, but I'm going to teach you a shortcut this time. If we have the equation in slope-intercept form, as we do here, I can just look at the sign to figure out which way to shade. Since this is a greater than sign, this tells me to shade up. So greater than, if we're in y, slope-intercept form means shade up because the y's need to be bigger. So the y's bigger, bigger y's, it's going up. So I'm going to shade on this side. And indeed, if you plugged in a test point, that's exactly what you would find. So remember, this shading represents all the different places where points work in that equation. But not only do we have one equation, we have a second equation, and I'm going super slow, so I'll speed it up. Let's use the beautiful green color. We'll make a nice Barney-colored graph. This second equation, okay, I'm going to graph this one as well on the same graph. So plus 6 is my starting point, and I'm going up 3 over 1, and down 3 left 1, going in the opposite direction. Here's the intersection point, but I'm not so much caring about the intersection point today as I'm caring about the collection of all points that work in this equation. So here's my second line. Since I have a less than sign, the shortcut tells me, since this is slope-intercept form with a less than sign, to shade down. So I'm going down, down, down. In other words, I'm shading on this side of the line. Now, if you notice, we have some shading that overlaps here. And you might have guessed that the shading that overlaps is the shading of the area where points work in both equations. So let's take a look at this. I'll kind of highlight it in black. This area right here that I'm highlighting in black, this area. This is the double shaded area. This is an area where points work in both equations. So what are some solutions? Well, I have, for example, 2, 2. If I put 2, 2 into both of these equations, they will work in both equations, and you can do it for yourself if you don't believe me. What are some other points? Well, here's 4, 4. Here is over 5 down 2. These are all points that work in both equations because they are in the doubly shaded area, the double shaded area. Now, if you notice, we do have some points that contain only purple shading, and we have some points that contain only green shading. Points that contain only purple shading are points that work in this first purple equation, but don't work in the other one. So, what are some solutions that only work in inequality 1, but not inequality 2? That would be points like negative 2, 7, for example. Over negative 2, up 7. or a point like this looks like -5 up 9. These are points that are in the purple, so they do work in inequality 1, but they don't work in inequality 2. Likewise, sections in the green, such as -6, 0, and -1, I'm making my points backwards because it is the end of a long day and Mr. Gregory is tired. Here are the correct points. I'm not actually tired. I'm full of energy. I'm just not thinking straight. Okay, there we go. So these are points that work only in the green equation. Similarly, we have some points. All of these points in the non-shaded area, these work in neither equation. So points like over -5, down 1, this is a point that works in neither equation because it's in the area of non-shadedness. But what are the actual solutions that work in both equations? It's only the double shaded area. So for this chapter, we're going to be graphing the lines. We're going to be looking for the double shaded area. Bring colored pencils because this is a fun one to color. Let's just do one example. I think this is very easy, so we'll keep the video short today. And for this example, we're going to be graphing, 3 entire equations. This is most confusing. I'll get to use 3 colors though, and it's actually not that confusing. Remember, our strategy is we're going to graph the lines and we're going to shade in the right direction. So let's do this. Y-intercept of 1. I'm going down 1 over 1, down 1 over 1. Let's use a solid line because I have greater than or equal to. So solid line, there we go. Looks beautiful, just like all of your shining faces in the morning. Since I have y greater than, and I am in slope-intercept form, I'm going to be shading up. So all the points above this line are points that work in the first inequality. And if you don't remember what I mean when I say work, go back and watch, I think it might be the 6.7 video or something. Like, we've done this before, really. You just maybe need to remind yourself a little bit of it. 6.7 video might be a good one to watch. If there is one, I think there is one. Okay, we have 2 other equations. And since they are just x and just y, these are going to represent, let's make my green a little darker. These are going to represent vertical or horizontal lines. If you remember, x with a number is a vertical line. This is a fact that you should have memorized. All of the points that I'm about to graph have an x coordinate of 4. So here is my x less than 4 line. It's going through an x coordinate of 4. Since it's less than, we can't really use the trick of shading up and down, but think about it. X less than 4. Where do lesser x's live? Well, lesser x's live to the left. More small x's live to the left. So I'm going to shade to the left of this line. All right, great. Finally, we'll do, I think, red. If x and a number was vertical, obviously y and a number needs to be horizontal. So here, y greater than 1, it's going through a y of 1, which is right here. And here I'm seeing that y is greater than y's live up. So I'm going to be shading up here because bigger y's shade up. Now, this graph is extremely messy, and I need to clean it up maybe. I can look at the triple shaded region, and I hope you see the triple shaded region. It's kind of right in here, but sometimes it helps just to shade really, really lightly and then kind of clean things up. I know the triple shaded region is right in here. So let's erase all my other shading using the magic of digital ink. And let's just shade where the triple shaded region was. The triple shaded region was above the blue line, above the red line, but to the left of the green line. So here's the triple shaded region. And all of the points in this region are the points that work. So points like, let's do them in red, maybe like over 0, up 5. This is a point that works. Maybe something like over 1, up 8. Maybe something like over 3, up 9. Or over -3, up 9. These are all points that work in all 3 equations. And if you don't believe me, you can test it out for yourself. But in order to save time, I'll let you work that out on your own. Hey guys, keep it real and see you later.